Hi everyone, welcome back to another video series I'm doing on this game I'm trying to build. Um, Basically, I did a past few series of videos on geosphere mesh system that I created. It could create a large planet sphere in like milliseconds. It was pretty fast. Terraforming took a little more time, but I wanted something more destructible terrain. I mean, who doesn't want destructible terrain, right? I wanted to create sort of like a virtual lathe system where I could easily create caverns and stuff within the planets and so on and so forth, which I think would be a lot easier with a voxel system. I can make some like random group of voxels and just use them as and use a series of them and then rotate through them as part of the lathe when cutting out caves and stuff and make some kind of interesting interior. My main challenge is that I didn't want to get into C++, although I can do it. It just gets tedious and very low level, which is what you want really for this kind of thing. But I mean, I'm quite versed in C#, and I know we can get into some very low level stuff as well. So I decided to go ahead and try my hand at it. I'll give an example of some of the low level stuff here before I get into showing you the results of it. Let me go ahead and look up this one thing here. I believe it was the merge operation for the voxels. So now the single voxel can actually be 1 by 1, 2 by 2, 10 by 10. The voxel is actually a node within the octree. So I created an octree of voxels. And so if you actually put 8 voxels together in the shape of a cube, the system will automatically create one big giant 2 by 2 by 2 voxel, right? So 2 by 2 by 2. So that'll automatically just become 1 with this, and it'll have a 1 with a radius extent of 1, right, from the center. And that'll be stored in the tree. Now, if you keep doing that, what if you have 8 of those as well, right? You group those together, and then you got a voxel that instead of being 2 by 2 by 2, now it's 4 by 4 by 4. And then if you have those grouped as well, then you have 8 by 8 by 8, and it goes on and on up the parent hierarchy. And so what it does is it automatically groups voxels of the same type together into large blocks. Now, to do that, I think that was one of the interesting challenges I had. In this merge check, the checks to see if it's time, if I should merge children upwards into the parent. There's this cool little C# ability now, which I don't know if it was available way back when I sort of was on a hiatus from the project. I sort of put it on pause for a while, but now on my return, with a little bit of checking to see how things have progressed, I wanted to see what kind of stack-related options I have, and this was kind of cool feature of C# now. You can actually allocate arrays on the stack. And why is this huge? This is huge because, I mean, basically now I can take a chunk of stack memory, right, and a scratch pad, right? And so I can basically get a list of all the types of, I only have 8 quadrants, so I mean, it's not like a lot, right? 8 child quadrants, and I put them into array, right? And it's actually grouped. So this is the type, and then the count of that type, then the type, and then the count of that type, and so on and so forth. So basically, there's 16 elements in the array, right? And it's actually 8 groups of 2. And so what this does, basically, it has a pointer to the end of the list and a pointer and an end pointer at the front of the list. So the end actually moves up from the front towards the end. And what it does, it scans through and it does a count of everything of the same type and then increments a counter. Then it goes to the next one, does a count of all that are same. If they're same as that, increments this counter, and does a count, and so on and so forth. But it does it in such a way that if the count is 0, if there's no match, that means there's nothing at all. It actually moves it to the beginning of the array by just simply flipping them around, just doing a complete swap. This swaps for the end and then increments the end upwards. And so what happens then is basically you just have a couple loops that go through, which is extremely fast, And the end result is just seeing, okay, if the end is equal to type's length, -2, then basically that means they're all the same. Then it can basically clear out any voxels, which just disposes them into a object pool, and then tells the parent, hey, you might want to check to see if, now that I've changed, that if you can collapse upwards as well. So this will just keep collapsing upwards, and there's no. The cool thing is the garbage collector is not engaged in any of this. Like, I can actually allocate a stack or array out of the stack, do some quick scratch work, check the results, and then I'm done. So I mean, it's quite fast, really good. It's quite fast. It works quite well. The only other thing I have on top of that would be this fast dynamic array. Now, I'm quite proud of how this turned out. What this does is it creates a managed buffer of bytes. And using fixed, I can actually fix the pointer. And Unity has a memcopy ability. So I can actually memcopy information if I want to, right? So let's actually go down here to the add. So here I create a buffer. Then, of course, I have the size of the... what is the size? So this buffer can store the top of the buffer type is T, right? For example, a structure of vertices, vector 3 objects, for example. And so T size stores the size of those. So I can get the size of T, right? Again, unsafe utility from Unity is quite handy. I can do some stuff that you normally couldn't do, which I believe should really be part of the native language for those people who want to get low level, right? I mean, I've been using it quite well, so I don't see any reason why they shouldn't allow it. I mean, it's just, it's kudos to Unity for implementing these utilities, so it's quite handy anyway. So here, for example, I can read an array element, and here I can write an array element. And basically what this does is it allows me to read and write element of type T. So I can literally have any structure size that I want as an element. It'll read that element and then copy it to the stack and then return it because it's a structure. It copies it as a value and pulls it out, which is beautiful, right? Now down here, when increasing the size of the array, I just allocate a new buffer, memcopy, right? Then I fix, which basically pins the buffer. Then I memcopy, right? Then I write the array element, right, that I want to add in this case. Now this is if it has to increase the size of the array. So just by using this low-level system here and doing like memcopy to be able to copy the old contents of the array, was able to give it a huge boost to the performance. So I mean, this everything, just being able to get low level here has been quite good. So let's go back to the Unity editor here. So you can actually see that like all these little optimizations, they're very, very handy. They do work quite well. And so all this does is it simply goes from through a loop. They create a block, right? The size 20 is a radius. So it basically goes from -20 to +20, which is 40. And then 40 by 40 by 40, which is like 64,000 voxels. So this is 64,000 voxels right here. Now, let me zoom in here a bit. I'm out a bit too far. I'll go ahead and zoom main camera. So if I click on this, it's going to erase certain blocks, right? Maybe I can zoom in a bit more. So you can see here, right? And there you go, right? So, and I can click in those blocks, and there you go. And now this is slow. It's 64,000 voxels because it's redrawing the whole thing over and over again. Now, when it does draw it, and also there's also making the colliders, right? And so once it's drawn, it's pretty fast. Let me go ahead and focus back on this again. So this whole thing is quite fast afterwards, as you can see. Like, look at this; it's really smooth because it's only rendering the shell on the outside, and you can see the blocks inside here where I kind of clicked on those down here as well, right? So you can see those. So there you go. So I mean, this is pretty large when you think about it. Like, like if this is like rounded off, eventually a planet, I'll have some rounding algorithm to round this off, and then it'll be smooth, and this will be a sphere instead of a block, and it'll be the shape of a planet, and I'll have like a lathe system to cut out like caves and stuff like that. So yeah, it'll be quite nice. And that's the system. Now this is 20. This is about 64,000. I could actually handle 1,000,000 voxels. So, but it's going to be a bit sluggish to draw it. I'm going to do 50. 50. It's 50 negative, 50 positive. So it's actually going to be 100. 100 times 100 times 100. That's 1,000,000. And so let me go ahead and let this compile. All right. Let's give it a moment. Click play. Now, when I click the mouse button, it's going to create the block. So right now, there's nothing there. When I click the button, so I click it right now, click. There you go. And just wait for it. Just wait for it. There you go. 1,000,000 voxels. It might take 2 or 3 seconds, but I don't know, 2 or 3 seconds is not a terrible amount of time necessary for 1,000,000 voxels. It's pretty fast. It's decent speed. And don't forget, this is not. This is, if you see down here, we're in debug mode. So if I was in release mode, and perhaps compiled as well, the final compile and release builds will actually probably be faster on top of this, right? So this is just debug mode, right? So in any case, it's pretty fast, which is nice. And let me go ahead and zoom out here a bit. Okay, reposition this a bit more. There you go. So as you can see here, like this is pretty big. Like this could be like a planet. If I rounded this off, you could easily see this being like a planet or something. Let me go ahead and zoom out here. Okay, so you can easily see this in here. So definitely, I mean, this would be like really, if this was rounded off, right, you would basically be on the edge here, right? And this would be like hills and mountains and some other stuff around here. And this is, this could really be a large enough planet, right? And it's 1,000,000 voxels. Now imagine this thing like a lathe system, which would spin around in one direction, and then on one axis, on Y, for example, and then it'll spin around on X, and then it'll just create this random zigzag through the whole thing. It's like a spinning lathe, and using a random set of voxels that I want to remove, and just keep doing that enough times, you can basically build caverns and stuff inside of this thing as well. So right now it's stuck to like a green grass terrain at the moment. It just gives it that green shade. But let me show you the octree. So to turn this on, you can actually see, it's a little slower now, that the octree grows from the center. As I'm drawing the voxels, it grows. And then it creates these other nodes, if you will. So each one of these blocks is a voxel. This is a voxel, but it's considered empty space voxel. So they represent an actual voxel, right? You can see, by the way, the coloring is how many voxels are actually inside. So you can see here, this block is a voxel, represents space. The voxels represent whatever is the most material inside them. So mostly it's space, so this represents space. If most of the voxels inside were grass, then this parent would represent, grass, for example, right? And then it would just delete all the child blocks and put them into the object pool because now the parent represents them, kind of thing. So in any case, you can see the blue line, the blue line, the blue line. So this little blue block is a voxel in the corner of this voxel, in the corner of this voxel. So the voxels are sort of like, so if I was to delete this voxel, it would merge the empty space into the parent voxel, which is empty space, which would then merge into the parent voxel, and which is also empty space. And then eventually, it would just delete this whole, like all of these child voxels would be put back, disposed, and put into an object pool for future updates. So that's it. So now there are colliders involved, which just allows me to click on it in the first place. Let me actually turn this off. Turn off the octree so you can see it's a little faster. And go to the collider. There we go. So now a collider holds a very large area, right? And that's a collider, 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 collider. So it builds colliders. I don't know why it's all over the place, but in any case, it's probably based on how it caches and stores the vertices. Sorry, the triangles and so on and so forth, the faces and everything. So I have to look into that. But basically, if you have 2 + 1 + 2 or 1 + 2 + 2, in the end you get the whole thing covered, right? And so there's colliders everywhere. Now I think breaking up the colliders into smaller chunks will allow me to hide and show based on where colliders need to be. So if there's an object that needs a collider, it'll show, and if not, they turn off. And so these will all be off, and this one. So if the player, for example, is right here, right, these will be on. And as the player moves, the colliders will turn on and turn off based on where the player is. So based on distance, right? And so you don't need to have all the colliders on, so to speak. So, but there we go. So the colliders are on. If I click, it is a bit slow, right? Because it's got to rebuild everything, right? So, I can click here. Let me see here if it's going to respond at all. Yeah, it's just really, really, really slow. I mean, you're dealing with like a million voxels, right? I mean, there you go. I mean, it rebuilt it. You can see a little spot down there, right? So it took it away there, but 2 of them actually. But it's going to be a bit slow because you are dealing with a million voxels. Now, one optimization I can do is that only the voxels in a certain quadrant or area of the tree need to be updated, and so that'll connect with the Hermite data and just deal with that accordingly. So it'll be a much faster updating just the area that has changed. So I'm happy with the speed of it so far. If I can increase the speed of the updates, I think 100 by 100 by 100 is a decent planet size overall. It would be the maximum planet size, and asteroids are usually much smaller than that anyway. So and then I wouldn't have to deal with compute shaders or anything like that. I could actually keep it the way it is. So I'm happy with the way things are, and we'll see how things go from here. So that's pretty much it, and I'll let you guys go with that, and until next time when I have more to show. Okay, thank you. See ya.